Okay, 4.7 pre-calculus is inverse trig functions. First, I want you to know that sine squared means sine squared. Cosine cubed means cosine of this angle cubed. But you have a special one if it's a -1. That does not mean an exponent. If it did, it would be 1 over sine, which is cosecant. But the -1 right here is very important. That means the arc sine. That is called the arc sine or the inverse sine. And it means the angle whose sine is. So, if I was to say the arc sine of 1/2, that means the angle whose sine is 1/2. From your trig table, hopefully we know it's 30 degrees or pi over 6. The angle whose sine is 1/2. The angle whose sine is radical 3 over 2 would be 60 degrees or pi over 3. Again, yes, sure. You may miss y. My domain and range are, but what is today? 25, right? September. I think it's so. Okay, I'm going to try to make this as clear as possible. Each one of them, arc sine, arc tangent, arc cosine, they all restrict the domain and range. So, what do I have down here on the bottom? Do you agree that this is a cosine? Okay, the bottom one is a cosine. And if I want to take the y values go from 1 to -1, do you agree? If I want to take all of those values, where on the x-axis is that between? 0 and pi. So the arc cosine, you can only return answers between 0 and pi. In other words, 0 to pi means quadrant 1 and quadrant 2. That's for arc cosine. It's the only one that's like that. All the other ones are from -pi/2 to pi/2. Please notice that arc cosine is the only one from 0 to pi. Here is a graph of a sine wave. If I want every value from -1 to 1, where would that be between? -pi/2 to pi/2. Would that get me all of the y values? How about for tangent? Here is a graph of tangent. If I want all the y values, where would I restrict it between? -pi/2 to pi/2. That means all the other ones, other than arc cosine, have to come from quadrant 1 and quadrant 4, because they have to come from -pi/2 to +pi/2. I'm just trying to show you why it is this way. Arc sine, arc tangent, -pi/2 to +pi/2. Arc cosine is the one that's 0 to pi. It's the only one that's different. Okay, these are just telling you what the restrictions are. Now here's some examples. To do these, we might need a trig table, so just bear with me. Okay, I created a trig table at the bottom. The angle whose sine, this is how you would read this. The arc sine of radical 2/2, or the angle whose sine is radical 2/2, which would be pi/4. So the answer for this one is pi/4. Arc sine has to return between -pi/2 and +pi/2. Between -pi/2 and +pi/2. This is between there. That is your answer. The angle whose sine is radical 3/2. Sine radical 3/2 looks to be pi/3. That is the answer for this one. Because again, arc sine is between -pi/2 to +pi/2. And this is between that. So the trig table could help with some of these. Okay, how about example 3? The angle whose cosine is radical 3/2. I would still use my trig table. Can you tell me the angle whose cosine is radical 3/2? So I want to look back here. I want the cosine to be radical 3/2, and what would it be? pi/6. So let's go back, clear that out real fast so I can go back and use it. So I get an answer of pi/6. The only problem is pi/6 is in quadrant 1. Everything is positive in quadrant 1. I don't want the cosine to be positive. I need the cosine to be negative. Cosine is the x value, is it not? Cosine has to come from 0 to pi. So if I want a reference angle of 1/6, your answer is going to be 5/6 pi. Because it has to be between 0 and pi, but you need the value of the cosine to be negative. Now how about the angle whose tangent is radical 3? The angle whose tangent is radical 3. I see tangent, I see radical 3, and I see an angle. So I think it would be pi/3. Now let's just verify it's in the correct quadrant, and we get the correct sign, and it'll be my answer. Because it's positive and it's in quadrant 1, and everything in 1 is positive, so it is in quadrant 1. The answer is pi/3. Okay, how about this one? The angle, many times sine and arc sine just eliminate each other, and my answer here would be pi/4. Now, listen to me though, real fast. What is the sine of pi/4? Radical 2/2. Now, what's the angle whose sine is that? It's positive, so that's be quadrant 1, so it's just going to be pi/4, right? However, look at this next one. You might think sine and arc sine eliminate each other because they are inverse functions. However, I think you'll find that may not be the case on this one. Let's see. Okay, I want to find the actual sine of 5 pi over 4. 5 pi over 4 is in quadrant 2. The reference angle is pi over 4. Tells me it's radical 2 over 2. In this quadrant, it's negative, positive, cosine, sine. So it is the sine, it is the arc sine of this. And yeah, I thought that was wrong. It's not quadrant 2. Where is 5 pi over 4? It's in 5 pi over 4 is bigger than pi, isn't it? Wouldn't that put it in quadrant 3 down here? Reference angle is still pi over 4, so I still get radical 2 over 2, don't I? But in this quadrant, it's negative, negative. So it's cosine, sine, so this should be negative. Now I need the angle whose sine is negative radical 2 over 2. Now, arc sine, if you remember, has to come from where? 4 or 1. And since it's not positive, it has to come from quadrant 4. So you're going to call that negative pi over 4. A lot of people are going to just assume that it's just eliminates each other. And they do many times. But not always. You have to check your signs of your quadrants, basically. How about example 7? We want the cosine of the arctangent. Arctangent means the angle whose tangent is. So bear with me as I make a triangle. It's not going to be to scale, so don't worry about that. And I'm going to label my angle theta. Tangent is opposite over what? Adjacent. So 5 12. Do you agree? Can you find your missing side to be 13 using Pythagorean theorem? Leg squared plus leg squared equals hypotenuse squared. Now I want the cosine, which would be adjacent over hypotenuse. So adjacent over hypotenuse should give me 12/13. I find the ones with numbers, people do pretty well. You just got to be careful when you get negatives because of the quadrants it's going to force it into. However, if they are letters, people struggle with them. So please bear with me and watch. Anytime it's an inverse trig, that means an angle. Specifically, this means an angle whose sine is x. So I'm going to make an angle. I'm going to label my right angle and my angle. And I'm going to make the sine of the angle x. Sine is opposite over hypotenuse. Opposite over hypotenuse. Is the sine of this angle x over 1? Okay, find the missing side. Could leg squared plus leg squared equal hypotenuse squared? With practice, you'll get good at this. Subtract the x squared and take the square root. So this is radical 1 minus x. Now I want the cosine. The cosine of this angle would be adjacent over hypotenuse. Adjacent over hypotenuse, which is a 1, right? So here's your answer for example number 9.